Okay, welcome. We're talking about converting to vertex form. So again, we're using a quadratic equation, which is ax squared plus bx plus c. And we want to convert that into the vertex form, which is going to show us in the equation what our vertex is with h and k. H being the x-coordinate of our vertex, k being the y-coordinate of our vertex in our graph. So basically, if we're looking at a graph, whether it's up or down, this is our vertex here. And so by converting to this equation, we're able to find this point, which is an important point because it really shows you what your graph is. Now, if I use an example like y is equal to x squared plus 12x plus 32, okay, what I want to do is kind of use some of the tools and skills we learned from completing the square. Now, in order to do that, what I want to do is get this, complete the square piece, we'll call it, by itself. So what I'm going to do is subtract 32 from both sides. And I'll rewrite that as y minus 32 is equal to x squared plus 12x. And then I have that space here to put in my perfect square. This is where my perfect square is going to go, my p square. Now, in order to find my p square, I'm going to use my b, in this case being 12. So I go 12 over 2, 6 squared, 36. So that's the perfect square I'm going to put in here that's going to allow me to factor. Now, because I want to change the way the equation looks, but not change the value, if I add 36 to one side, I also want to add the 36 to this side here. And then when I simplify, I end up with y plus 4 is equal to x squared plus 12x plus 36. And if I factor this section here, I could factor this into x plus 6, x plus 6. And because it repeats, it ends up being x plus 6 squared. And already I'm kind of seeing the creation of that x minus h squared piece of my vertex form. And then final piece being getting y by itself, where I could get y is equal to x plus 6 squared minus 4. And this reveals to me, using this equation, that my vertex is minus 6 minus 4. This is my h here, and this is my k. Now, the reason you see a switch from plus 6 to minus 6 is because, don't forget, it's x minus h. So in order to get a plus 6 in there, I must have done x minus a minus 6, which would have gave me x plus 6. So my h, in fact, ends up being a negative 6, which is what I have here. Question?
So if the 6 would have been like x minus 6, it would have just changed into...
It would have just stayed 6, yeah, because if it was x minus 6, then my x minus h, if I have x minus 6, then simply my h in here was just a positive 6. Now this doesn't have a coefficient in front of it, so it tells you it's just your normal shape of a parabola. Remember, a greater than 1 is narrow, and a less than 1 would be wider. And you'll see that in the next question, which I'll show you more so when they have a coefficient. So let's look at a problem that has a coefficient like 2x squared minus 16x plus 29. And if this is a quadratic formula with a, b, and c, then y is equal to that quadratic formula. Now again, just like the last question, I want to get my complete the square piece onto one side. So I have y minus 29 is equal to 2x squared minus 16x. And here's my complete the square piece. And because I've gotten that by itself, I'm actually able to factor out a 2. And if I factor out a 2 from 2x squared minus 16x, basically what I'm doing is dividing each by 2. So I end up with y minus 29 is equal to 2 on the outside, because that's what I factored by, x squared minus 8x. Remember, that's where I made the mistake on the last example I showed, is that I actually forgot to divide the 16. Now this piece allows me to put in my perfect square here, which is my b, negative 8, divided by 2, squared, which is my negative 4, squared, which is negative 4 times negative 4, which is 16. So here I'm putting in my 16. Now here's the tricky part. If I add 16 to this side, what do I add to the other side? Oh, I add a 32. Wait, what? What just happened? Well, keep in mind you have a 2 on the outside. So if I'm adding a 16, technically I'm taking this 16, multiplying it by my coefficient here, and ending up with this 32. This 32 comes from doing the 16 times 2. So when you convert to vertex form, make sure you're taking your perfect square you added and multiplying it to the coefficient and then adding it to the other side. That's different from the previous question, and this is probably the part where most students would make an error. Well, not you guys. You'll probably get this right. And then we have 2, and then if I'm going to factor this down, remember this would factor down to x minus 4 if I'm to unfoil it, which would give me here x minus 4 squared. And if I'm getting the y by itself, let's use like this one here, minus 3, I end up at y is equal to 2, x minus 4 squared minus 3. And just like Jaden was telling us, here we have x minus a number, so that means my vertex ends up being a positive 4, because remember this is x minus h. And in this case it's just x minus, what's your h? The 4. So that's just simply your 4 there, a positive 4. And then keep in mind too, we talked about our a being here, and in this case our a is greater than 1, which would in this case make it narrow. So, and because I have this vertex and I have this idea of my parabola slope, I'm able to go to a graph. I'm able to go to positive 4, 3, which would be somewhere here, and then maybe make a little bit more of a narrow graph, up 2 over 1, up 2 over 1, and kind of come up with how my graph would look because I converted it to vertex form. This is a great tool to have if I don't have a TI-80 something or Desmos to put into a calculator where I have to graph. But we've seen, so many different ways of graphing this using the negative b over 2a, and so there are a lot of different ways and tools you could use to graph quadratic equations. I hope this helps.